Okay, well, welcome in everyone. My name is Trig Minnick with MRG Labs. Can everyone hear me okay?
Yes, we can.
Yes, we can hear you.
All right, excellent. Well, today we have a slight twist up for you. Normally, Rich Wurzbach does the demonstrations for us. He is unavailable today, but I think he's kind of on standby as he can. Um, anyway, so instead today we are going to hear from Richard Janowski. Richard has been with MRG for about 8 years now, and for about the last three, he has been our lab manager. He has a BS in chemistry, where he also did some research in analytical techniques and organic synthesis. See, he can do all that stuff, and I can barely even say it. Richard has also ran more samples through a grease thief analyzer than anyone in the world. Not only has he ran samples, he's repaired the machine, helped put them together. He is a definitive expert in the grease thief analyzer. So we hope some people can catch him in the number of samples he's run, but right now he's the leader. So today, Richard will walk you through dye extrusion. You will get a demonstration of how we get what we call a GTI reading. He'll talk about what that means in regards to grease consistency and how this is a valuable method for used and new greases. And he even hit on some of the ASTM standards around this. So without further ado, I am going to turn on both my camera and my microphone. So if there's anything offline that you would like to say, put it in the conversation bin there, or chime back in. But otherwise, just keep your microphone off so it stays fluid for the rest of us. So without further ado, Richard, take it away.
Thank you very much for that introduction, and welcome everybody to Greasy Thursday. We'll be talking about consistency testing per ASTM D7918, so our dye extrusion method. So we're going to start out today with talking why dye extrusion. Historically, cone penetration has been used as a test to assign the NLGI grades for new greases. This is a static test and oftentimes requires a very large amount of grease, and that is oftentimes not possible for a customer who's running a small bearing or piece of equipment, and it's just not feasible to get that, hundreds of grams, even, pound of grease. Dye extrusion is helpful in the fact that it monitors dynamic consistency change and flow properties of grease samples. It does that with a load profile that measures at varying speeds, that creates varying shear rates on the grease, and it measures that response to those changes and then provides data to the customers in the report later that we'll get to. It also provides control of the test parameters such as the positioning, the extrusion rate, and the temperature of analysis so that it's performed repeatably and the same on every sample that goes through the instrument. Grease is extruded through a small die to create a thin film onto a substrate. And this test can be performed with approximately 1 gram of grease. So, up to, if it's completely full, we might have 1.5 grams in a grease thief. Some of the analysis techniques of ASTM D7918 that we're going to be talking about. It was approved and published in 2015. On top of the dye extrusion method that we're going to be showing today, it includes particle counting, moisture in parts per million, colorimetry that we've covered, ferrous debris that we covered, ruler, elemental spectroscopy, FTIR analysis as well. So we can do all of these tests with 1 gram of grease, and then as you see on top there, We have our extruded sample, which shortly we'll be running through an example showing you how we prep and do that for a sample. But you can see that thin ribbon that is extruded across the substrate. And then it's nice that you can see in the picture, there's individual sections that be peeled off. And then each section can be used for its test. And it's nice that you don't need to rely on a scale. It's prepared and ready for further analysis after you've done die extrusion. So then the test results that we get from die extrusion, you're going to see the reported value is what's called the grease thief index, or you might see it GTI on a report as well. This gets reported out, and it's a load value, and you want to think of it as 100 would be a perfect match to the reference baseline in its force profile. So a 100 being a perfect match is what we want our samples to be close to. Obviously, as the grease is in service, it may start to harden or soften. When that happens, we'll see the GTI increase or decrease. So there we have, obviously when the grease is above 100, it has hardened, and that grease is requiring more force to follow the same extrusion profile as the previous tested samples or the reference baseline that you're comparing it to. And then inversely, if the GTI value is below 100, the grease is starting to soften. And then we'll see that go down and down and down throughout life as well as the grease is worn. Some other things that we might see in the graphs, and we want to make sure that we don't allow them to influence our reading, would be air bubbles. Sometimes it is challenging for customers when they're packing a sample, and they do get a little bit of air bubbles in there. We talked about that in previous Grease Thief Thursdays when Rich was showing sampling techniques. And with the instrument, we'll be able to peek and take out the influence of the air bubbles and large particles that may be in the grease. That way we're making sure that we're reporting the true consistency of the grease and not allowing anything that's in it to influence it. Next, we're going to run through just a couple of graphs to show you what the image from the analyzer is. Here you have the grams of force is what's graphed to extrude the sample. And on the blue line is our sample. The red line is always going to be your reference sample. And here we see these two greases almost identically match up. So this is a almost perfect response from the used grease compared to the reference grease that's going in. So we know that this grease is performing over the step changes we see here in the exact same manner. So next, we're going to see an example of a grease that has started to harden. So here we can see the blue line is much higher, and it has required more grams of force, almost twice as much, to extrude that grease. So we know that this grease is going to require more force and be harder on the machine when the grease is running. Here's an example of our GTI below 100. So this grease has started to soften. And here you can see that in the blue line is well below the reference sample. And it is much softer than the grease that's being put in the equipment. So here we have an air bubble in the middle of the graph in the blue line. When that depression drops off and then comes back up, in the software, which I will review later when we run a sample, we have the ability to go in and we can remove the points on the graph right here, and they will not influence the GTI calculation. And then we will make sure that we are avoiding that influence of the air bubble where there's no force required because there's nothing to push on in the grease thief. And then the opposite case of this would be is if you have a large particle that gets pushed through. Here you'll see some spikes, some localized spiking or force, spike in the force from a particle going through the extrusion die. And the same way, we'll be able to use the software. We'll work through, and then we would pick out those points that the particle's response does not have an influence on the reported value to the customer. All right, and now we will get ready to show the grease thief analyzer and do some. All right, awesome. Everybody can see here, we have the grease thief analyzer. On the front, you have a small HMI screen that allows you to control it. It's gonna run your calibration. It's gonna run samples. It allows you to turn the heating rack on and off. So on top, heating rack samples are put up there. That maintains their temperature and that each sample is running the same test. So here's one prepared already. I will show you how to prepare a sample as well when we get to it in time. And then back, we have where we're gonna load up our substrate. Show you we saw that in the picture, but here we can see this individual substrate. This is what comes for samples. And then after the grease would be extruded, we would be able to pull that substrate section right off and take it out and use it for our analysis in the lab. When a sample arrives to the laboratory, it's in a closed position with its cap on. It normally is also in its travel tube. I've taken it out of the travel tube already. To prepare our sample, simply going to take our cap off, and then we're going to thread our sample tightly on there. And then now I'll take this, I'm going to place it in our heating rack, and then I'll allow that to come to temperature. That is how we ensure that all samples are run in a uniform manner. And then next I'll have a sample that I've already prepared, and I'm going to get ready to run that for you and show you the extrusion method. We talked about the substrate. So I'm going to move you closer so you can see what I'm doing. So we have our substrate. We're going to slide that in our substrate holder. Make sure that that position is locked. We have a sample that we'll take off the heating rack, and that gets loaded inside the instrument. And then on the screen, I'm going to wait for the temperature to hit the correct temperature to start the test. Sorry about that movement. There's a safety feature. The door has to be closed on the instrument to be able to perform a run. All right. So we can see our sample in here prepared. When we talked earlier, we talked about the different extrusion profiles. We wanted to get the camera close enough, and you can see this when we go to run the extrusion profile, you'll see the different speeds. So shortly, it's ready to test. So I'm going to go ahead and I'm going to start this extrusion test. So we can see the table starting to move. The grease is being extruded out onto the substrate. This is kind of moving at a what looks like a quick speed, you might notice. This is the fill profile, making sure the grease, if it's not full in the grease thief, has filled the extrusion die completely. Now we've hit the first load profile, which is the slowest. Sometimes it almost looks like it doesn't move for a second. We'll see it speed up again. The second load profile it's reported is the fastest speed. And then we will see it slow down to the middle speed for the third load profile. So these are what we talked about earlier, the step changes to see how that grease is responding two different shear rates. All right, and our sample
Richard, can you hear me?
extrusion, sorry.
Richard, can you hear me?
Yes.
Yeah, it looks like you're focused on the door on that one, so it's kind of tough to see. Can you maybe keep the door open or adjust the focus if you do a second one?
Due to the safety feature, we are unable to open the door and run the extrusion at the same time.
All right. So I'll slide this back. Now take this out. So our sample slides out. The next step, and you'll have to come back next week to see, is in the analysis would be particle counting. That's what the flat camera is there. So we'll be showing you how to do that next week. Come on back to see that. Here, this is a brand new baseline. You'll see on the sides it has some toothing. This is due to the tackifier in the grease. This is a kind of an anomaly or something that we often see in brand new greases. And then I have some new greases to show you, or sorry, in-service greases to show you. And that'll show you the difference where they have a smoother profile because that tackifier is gone. So both of these, same grease, just one's a little darker than the other. May have more contaminants, it may have aged more, it just got in the lab. We haven't completed analysis on this yet, but you can see that these are smooth, complete ribbons that are extruded. They don't have any of that toothing that happens from a baseline sample. All right, and then next, be able to show you the software and what we're going to do to get our data. So after run, and on here we can see, I didn't show this before, I can show it now, I did forget, I got a little nervous when I started. The load cell is used for calibration. You can see this here. This would get loaded just like a grease thief sample. If you see in the middle, it's got that same sized opening. It'll get held by the holder inside. This gets compressed, and we're measuring the slope of the force graph to make sure that it reads correctly, and that's how we're calibrating our instrument. So when we're in the software, then it's as simple as going to our samples, importing, finding the sample that we just ran. So mine is right here by time and date. I import that row. And then here, we're going to be able to add. So there's not anything in here. This is a brand new unit that actually just arrived in the lab Monday. But once it's set up on site, there would be operators. You can do this by simply doing quick add. I will add myself. Operator, do a quick add for a customer, and we are the customer. Depending on the information they supply you, you can put in location, equipment information, equipment type, any OEM information, the application, and then finally you would be able to assign the baseline, and then that's how you'd be getting the resulting images that I shared at the beginning for the customer. Once we are satisfied with the information, we would hit save, and then it comes into our field and have all of our samples loaded, ready to go. From here, we would hit the reports and graphs, and this would get our sample ready to go. All right. I know the other thing we had to talk about, kind of one thing that we'll get out of this, and we mentioned it slightly, is that our die extrusion is measuring the dynamic flow properties or consistency changes that have an influence on the grease's properties when it would be changing, whether it be hardening, softening, leaking oil, what have you. So the die extrusion provides value to be able to quickly get that reading, be able to know you're changing your grease, and then if you need to, you would be able to take maintenance action, whether it be changing, lubrication frequency or actually needing to go out and have planned maintenance to fix an issue on equipment. Also, one thing that we want to talk about is how the GTA can be used not only for in-service greases, but it can also be used for grease manufacturers to do batch testing. So, as we talked about in the beginning, cone penetration, the test needs to be done on brand new batches of grease to assign the NLGI grade. And the grease thief analyzer could be used as a quick test to make sure that our sample or the batch sample matches the kind of the golden standard or reference at the baseline at that point for their customer. And they would be able to then ensure that when they go to do their cone pen, that it would pass, saving them time from having to run multiple. They will be able to trim that down, be satisfied with the batch, and then when they run their cone penetration, they will be able to have a successful run. So is there any questions at this point, Trig? I know.
Yeah, Richard, there are some good questions being exchanged in the chat that Rich is handling, but I think they
See
would.
the question coming in. Yes, when you see on the sample results clog, the extrusion die got clogged in the process. So likely that means that there was an accumulation of particles that would have required a force that would hurt the load cell, so it's prevented from causing damage to itself in the force reading, and it would be stopped, yes.
Rich, there were a couple of other questions earlier on that Rich handled in the group, but perhaps covering them, Rich handled in the chat, but perhaps covering them in the group would have some value here. Would you like me to read those? Oh, you can't hear me. He doesn't have speaker.
Can Marissa, maybe you can transfer to Richard our messages and. Can Richard plug in a headset so he can hear us? Or turn on a speaker?
All right. Reviewing some questions that we've had in the chat and were answered by Rich, but just for the benefit of everybody, I'm going to make sure I read them out loud. First question was, at what point would you recommend changing your grease out? When the GTI level has doubled? Question mark. All right. So as a default, we use a criteria of plus or minus 20 of the reference grease value as triggering further testing or investigation. There are some applications that we have found the grease type, machine working, or kind of load, for example, they might have a different set of criteria where it might be plus 20, minus 40 for a wind turbine. The main bearing on a wind turbine, the grease, oftentimes the consistency will drop quicker right as it goes into service, but then we see it maintain that lower level once it's thinned out just a little bit. Next question I see is that, is the grease bearing is the grease rehomogenized during the extrusion process? If so, does it have any impacting on consistency or shear readings? So answer here is, to a certain extent, there is mixing as the grease is rearranged as it travels through the flow channel. But no, the sample does not homogenize the grease prior to testing. that would change the consistency of the sample state if you would homogenize the grease. And then there's a follow-up question to that, and the answer to that was the advantage of running a sample through the flow channel is that variations in consistency that might be there due to hard sections of grease or softer sections of grease can be seen in variation along the extrusion profile. So we have seen that sometimes where at the beginning the GTI profile is lower or softer, where there's a different grease. And then as you get to the back and it's two different greases mixed in the grease thief, the consistency value, the GTI profile will change for that second portion that gets into the extrusion profile. All right. And then next I see is, do the results we see from die extrusion tests have any correlation with shear viscosity? So answer this, shear viscosity or apparent viscosity is a specific test that can be performed on grease at a given shear rate. As a non-Newtonian fluid, grease's viscosity varies based on the shear rate. So this is how a rheometer can be used to test and evaluate grease flow properties. So it's a different flow property. And I do not see any more questions at the bottom. Anybody else have a question?
Can you hear us, Richard?
No, he cannot, but I would be happy to tell you to translate for you.
Okay, can you ask him if it's possible to try to run another one? We have some time here. We were out of focus when he showed us the first time because it was focusing on the door. Can he either do a manual focus of the camera or defeat the interlock so the door can be left open while he's doing an extrusion?
Yes, I can see if we can have that set up.
Yeah, it's a little bit of time, and I think it would be helpful for folks if we could see that.
So I got over here. I'll just show real quick a prep to the prepping a sample. All right. So just re-demonstrate some skills that Rich has also shown before, but as a laboratory, this is also a skill that may be necessary. At times, you may have a customer that's going to send in a sample that does not work, or it does not in a grease thief. They send it in a bag or any type of container that they have available to them. So in the lab, we have a box of syringes, just like is in the grease thief kits. Remove the end, have our open end. Sorry, I missed the camera. We're going to use our spatula. We will place that grease inside of our syringe. So we get that packed up. I think I might need just a little bit more. All right. Don't get grease on my fingers. So then we'll have the syringe put back in. And then as Rich said before, we want to make sure that we push together our two ends really well. And then we're going to slowly introduce that grease into the grease thief. Pushing the grease thief and the syringe together will cause the piston and the grease thief to backseat, filling the back end of the body. And then once it's full, I'll let go and just continue to squeeze and then catch the grease thief so it doesn't fall. And now the front end of the grease thief is full. All right. So we're ready to prepare this sample for dye extrusion. So I'll take you guys back over in front of the analyzer. So again, have the grease thief with its cap off, the extrusion die, and we're simply going to thread the two pieces together. We'll have these in here, and then we're going to load our sample up. Get you closer. All right. The sample comes inside the grease thief. Sorry. Push it straight back on the bracket, and then that make sure that it's lined up on the load cell. Just swing the door around. Probably. Carefully gonna close this door. I put the camera inside the unit this time. Let me just make sure that it's facing a little bit more downward so you see the whole extrusion profile. Sorry about that. All right, now I think we're ready to go. Okay, so we're waiting. We're now checking on the outside. I can see on the screen that the temperature has come to the, Also going to load our substrate up. So you'll see that here when I come in. Simply lifting the lock up and over. Substrate gets fed between. And then we're going to lock that down. All right. We're at the correct temperature. So I'm going to go ahead and start the extrusion. So as I mentioned earlier, the first profile is the fill profile. So you're going to see it and it'll look like it's going quite fast along the extrusion profile here. In the top of the picture, you see the actuator coming down, following the extrusion profile, same with the horizontal cable that catches the grease on the ribbon as it comes out on the substrate. So now we're gonna just hit our slower extrusion profile. It'll almost look like it's not moving on your video feed. It's moving very, very, very slowly. And then next, it's going to pick up its speed. All right. Get our camera out. Okay. And I think the other one, just real quick one for anybody, we'll review real quick on the standard. We can kind of see the steps we went through. So on the right side here, you'll see at 12.2, talking about the analysis of grease by dye extrusion. So the top talks about the factory calibration the instrument comes with, the routine standardization that the customer would be performing. We talked about that, and I showed you the load cell, or sorry, spring in a can that we use to calibrate the unit. You can see here, steps 12.3.1, there's the loading the substrate up, You then prepare the sample from the heated tray into the holding block. Then here in the standard, you see where we talked about the extrusion profile rates. So those are listed in the standard for the grease extrusion. And then talks about, at the end of the test, removing the passive grease and then preparing your substrates for the additional testing afterwards. Yes, next week we're going to be doing particle counting for the grease thief. But that is the black camera that's right there next to the grease as it extrudes out. So if you're interested in finding out the value of grease particle counting and what it can do for you, come on back next week to hear about that. All right. Just told I missed one question that got out in the chat. All right, that's a very good question. What if we don't have reference sample to compare results? Can we have valuable information without baseline or comparing the grease with a similar fresh grease that has the same NLGI grade and thickener type? Using a different grease with the same NLGI grade would not be preferred, but it would be better than no reference grease at all. Greases with different formulations but similar thickeners might not give the same results on die extrusions, so the baseline would not be the best. It wouldn't be representative. We definitely have customers who they have more greases than they know. You know, it might be 4 or 5 greases that we're finding, and they only can send us a baseline of 2. But the baseline definitely adds a lot of value to the test because it allows you to compare how the in-service grease has changed compared to that reference lube. Yes, the newest version of the Grease Thief has some updated software features. So, as we mentioned, next week the Grease Thief Thursday is on particle counting. So that is over some units that are out there. Not everybody's using a particle counting unit. So that is one of the new upgrades. Internally, there's been some upgrades as parts. The HMI screen now has the software now has a pause button. So during extrusion, if you notice a sample or something just seems odd, or if you notice in the standard, it'll mention that you should watch the force reading on the screen start to go up. So this would allow you to pause the sample, fix it, and then continue on its way down the extrusion process. The table is offset in this. Might have been difficult to notice that when I was holding the camera, but you'll see that the horizontal axis sits that bar. So this bar sits offset from the table, so that way the table is directly lined up over top of the camera for particle counting, and it allows that process to be streamlined as well, where you don't have to make any kind of adjustments on the substrate. The sample is ready to go for particle count during your die extrusion process, and it makes that a much more streamlined process for analysis. And then the last one, see the substrate, which I did mention. I'll show that again real quick. on here. So this is nice that in our laboratory, we know that we're taking this off, and it might be, 1 for ruler, 1 for moisture, 2 for our RDE. So it's really nice that as a lab technician that I'm saving time and efficiency when I'm running my samples, that I know that the thin ribbon is a repeatable extrusion profile, and I can pull off each substrate and it's a repeatable weight. So it's nice for preparing samples that I'm not living at a scale, also having to weigh out my grease for each time. It's, unfortunately, like oil, you can pipette it out with a precision pipetter. With grease, we can't pipette it out, so it sometimes can be cumbersome and involved if you don't have a instrument to prepare your grease for further analysis. Thank you, everybody, for joining us in.
Like we have ended. He cut off just a second soon. Well, we appreciated everybody being on, and we look forward to seeing you guys next week as well, where we talk about particle counting with grease. So thanks, everyone. Have a great day.